These are the worked out solutions for our homework in Algebra 2, Chapter 8, Section 5, numbers 1 through 12. These are equations that are reducible to quadratic form. This is a list of the 12 problems that I asked you to do, and I want you to look at how we're going to change each of these into some problem that looks like quadratic, even though they do not start off being quadratic equations. And remember, this was U substitution. So in problem number 1, I'm always picking that middle term there. Everything's in decreasing order, and I'm looking at that middle term, and that's where I'm going to find my U substitution. So I'm going to say let U equal the square root of x. And then I also think about that if that's true, then when I square U, I would square the other end, I'd get the square root of x squared, which is x, which happens to be that first term. So I'm going to be doing that substitution. I want to show you that for each one of these problems, that in problem number 2, I'm picking that middle term, and then I'm going to square it, to get U squared, and then I notice, oh, that's the first term. In problem number 3, I said that you let U equal x squared. And so U squared would be x squared squared, which is x to the 4th, again, that first term. Problem number 4, the middle term, let U equal x squared, and just like in problem number 3, we get that U squared is x to the 4th, which is the first term. Number 5 is a little bit weird looking, except that just look at that middle term, and let U equal the quantity x squared minus 6x. If I were to square the U, I get the quantity x squared minus 6x squared, and notice that that is the first group kind of terms. So that I'm going to use that as U squared. In number 6, it's the same idea, that I look at that middle grouping and call that U. And when I square U, I have to square that grouping, and that happens to be the first part there. Number 7, let U equal that term, x to the negative 1. When I square U, so U squared, I square that x to the negative 1, and I get x to the negative 2, which is the first term. In number 8, I do the same thing, and I find that it is the first term, or I should say it's the variable of the first term. And then in number 9, I've got let U equal t to the 1/3. For U squared, I would just square the t to the 1/3 and get t to the 2/3, which is the first term. And then we have it in number 10, z to the 1/4, and so U squared would be z to the 1/4 squared, which is z to the 1/2. Remember, you're multiplying that 1/4 times the 2, and that gave us the exponent of 1/2, which is the first term. In number 11, very similar to problem number 1, I have U equals the square root of x, but when I square the U, I can just leave it. I'm not going to actually change that to x. I can leave it with the square root of x squared, and then I see it's in the exact same form as that first term right there. And in number 12, I'm going to do this, make this term be my U, which is the 5th root of t, and U squared would be the 5th root of t squared, which can be written as t squared underneath the radical symbol of the 5th root, which is the first term. So please look at all of these and notice that what I've circled in red in each one of these problems will become U. And what I've circled in blue in each one of these problems will become U squared. So each one of these 12 problems, I'm going to stop having x's or t's or z's or whatever's there. I'm only going to be using the letter U, and in each case the blues will become U squared and the reds will become U. So let's see each problem worked out. So here's problem number 1. I just copied it and put it here, no different than what you saw on the previous page. But now I'm going to actually do that substitution in. Where I had circled in blue, I changed that to U squared. Where I had circled in red, I changed that to U. I notice that now it's just a quadratic that is factorable, and I get U equals 9 or U equals 1. But I'm not here to solve U, I want to solve for x, so now I resubstitute backwards. And so instead of U equals 9, I have the square root of x equals 9, or I have the square root of x equals 1. To solve that, I would square both sides and get x equals 81, or I square both sides and I get x equals 1. And the final answer are those two solutions. For problem number 2, let's just cut to the chase there. I have the same problem again. I cut and pasted that. So I do the substitution in, and now I have 2u squared minus 9u plus 4. It's factorable. So I factor it. I solve for u, and then I remind myself I'm not here to solve for u, so I need to resubstitute back in, and I get the square root of x equals 1/2, or the square root of x equals 4. Remember, to undo square roots, we just square both sides, and I get x equals 1/4, or I get x equals 16. My 2 answers. For problem number 3, again, I'm going to do that u substitution, so what I circled in blue becomes u squared. And if you can't remember why that is, remember what I have over here, what I've written over here at this place. I've got why those substitutions worked out. I start with the middle term, find it for u, and then I square it to find that I've got the first term. I know that this quadratic is factorable, and I get a binomial squared, u minus 5 quantity squared equals 0, which means there's only one solution for u equals 5. But I'm going to substitute back in with my x's, and so x squared equals 5. I take the square root of both sides, remembering that I get both positive and negative square roots. And so I get x equals positive or negative square root of 5, and that's the solution. Number 4, do my substitution in. It's factorable. I solve for u. Remind myself that I'm not here to solve for u. Resubstitute back in the x's. Solve for the x's, so I'm going to take the square root. Remember, you get positive and negative, so I get x equals positive and negative square root of 2, or take the square root of the other one, and I get x equals positive or negative 1. So I have all of those answers. For problem number 5, I'm doing the substitution in, factoring, solve for u, resubstitute, and I go, oh, okay, these are a little bit more interesting. Each one of those, when I resubstitute it back in, I have to solve another quadratic. So I subtract the 7 from both sides, and then I notice that that is factorable. I get x minus 7 times x plus 1, which means x equals 7 or x equals negative 1. Well, that's great. I'm trying to solve for x, so that's good. But don't forget I have a second quadratic I have to solve for here. So I add 5 to both sides to get it equal to 0, so now it's in standard form. It's factorable, and so I get x equals 5 or 1. So these are my solutions, but I'm going to write them all out as one final solution. I have these 4 different numbers, numeric answers for this problem. Remember to pause the video. You can, look at this longer if you need to. Problem number 6. I'm going to do my u substitution, factor it, solve for u, resubstitute back in the x's, and once again I have expressions here, so I'm going to have to solve for x. So I'm looking at this, I'm going to subtract the 1, and I get square root of x equals negative 4. But wait a minute, a square root can't equal a negative number, so this isn't even possible. So that's out of the picture. Now I need to start working on the other problem, and so I subtract the 1 from both sides and get the square root of x equals 1. Squaring both sides, I get x equals 1, and that's the one and only solution to this problem. Number 7, I'm going to do my u substitution again. So I've got u squared minus u minus 6 equals 0. It's factorable. I solve for u. I then resubstitute back in the x to the negative 1. So I've got x to the negative 1 equals 3, or x to the negative 1 equals negative 2. And then we have to run. So what does this negative 1 mean, this exponent of negative 1? I want you to remember that a negative exponent means the reciprocal of, okay? And this is just the first, so it's saying that just the reciprocal of this number is 3. Well, if the reciprocal of the number was 3, what was the number? What number has a reciprocal that's 3? Well, 1/3, because the reciprocal of 1/3 is 3. And so That's one of the answers. If you're not sure and you want to see this algebraically, watch what I do here. I've got x to the negative 1 equals 3. If I raise both sides of the equation in negative 1, that means on the left-hand side I have x to the negative 1 to the negative 1. I multiply those powers and I get x. And x equals 3 to the negative 1. Well, 3 to the negative 1 is 1/3. So that's the other way to do it. So once again, on this other part here, I've got x to the negative 1 equals negative 2. I'm asking for the reciprocal of negative 2, which means it's negative 1/2. And so I have these two solutions, x equals 1/3 or x equals negative 1/2. Problem number 8, we're going to do our u substitution. I'm going to just speed through these a little faster. Remember, you can pause to watch these again, see them a little bit more. I do the u substitution. It's factorable. I solve for u. Then I resubstitute it back in, remembering that the negative 1 power means the reciprocal. So I've got x equals 4/5 or x equals negative 1. Those are the two solutions. Number 9, I'm going to do my u substitution. So I've got u squared plus u minus 6 equals 0. It's factorable. I solve for u. I substitute back in my t to the 1/3. And I have t to the 1/3 equals negative 3 or t to the 1/3 equals positive 2. We want t to the first, not t to the 1/3. So if I raise both sides of that equation to the third, I get t equals negative 27, because negative 3 times negative 3 times negative 3 is negative 27. Or I do the same thing to the other equation for t. I'm raising both to the third power, and I get t equals 8. And there's my solutions. For number 10, I do my u substitution. It's factorable. I solve for u, and then I resubstitute back in. This time I'm going to be using z to the 1/4. So z to the 1/4 equals 2, or z to the 1/4 equals negative 1. But the 1/4, meaning the fourth root, cannot equal a negative number, just like the square root can't equal a negative number. In fact, no even root can equal a negative number. Even if we're in the complex world, it doesn't. We're not going to get that. Okay. And so we've got only the other problem, and we've got z to the 1/4. We raise it to the 4th power, and so z equals 16. And that's the only solution to problem number 10. Z equals 16. Number 11, we do our u substitution. It's factorable. We solve for u, and then we plug it back in with our square root of x. Square root of x equals negative 9, or square root of x equals 4. Once again, the square root cannot equal a negative number. Remember this is not complex. Complex would be the square root of negative 1 equals I. This is saying the square root of something equals a negative number, and that's not a complex issue. It doesn't exist. So now we have the square root of x squared equals 4 squared, and we get x equals 16. Number 12, our last problem, we do our u substitution. We factor it. We solve for u. We resubstitute back in. Now we're asking for the 5th root of some number equals negative 2, or the 5th root of some number equals negative 3. It's an odd index, not an even index, but an odd index. So this is okay. We can have negative results for odd indexes. We just raise both sides to the 5th power, and we get t equals negative 32. Or, again, raise everything to the 5th power, and we get t equals negative 243. And these are the last two solutions for the 12 problems that I asked you to do in Chapter 8, Section 5.